Placing pedicle screws requires millimeter level precision. In my previous video, I demonstrated how consumer VR hardware can be used to mimic surgical navigation technologies. However, one problem arose. Although surgical navigation can show you where the drill is, it doesn't guarantee where the drill ends up. That's still up to the skill of the user. There are many ways to solve that problem, and one of those is using drill guides like this. This drill guide is customized to perfectly fit into one location along a vertebra. And when it's in that position, it perfectly aligns these drill guide holes to make sure the trajectory of a drill is constrained to the desired path through the pedicle. To create the custom guide, we need to start by obtaining a digitized version of the vertebra. While surgeons would use a CT scan, I'm obviously taking a different approach. I previously used an iPhone's LiDAR system to digitize models. However, that lacks the accuracy we need here, so I upgraded to this, a Photoneo Foxy M 3D scanner. This scanner uses structured light to digitize an object in its field of view. By placing the vertebra on a stand on a turntable, I'm able to create a series of scans around the vertebra to generate a 3D point cloud. With the point cloud generated, I can plan the desired screw trajectories. In my previous video, I used wood screws, but this time I have access to sample lumbar pedicle screws. To ensure the trajectory is appropriate for the screws, I digitize them in the same way as the vertebra and place them relative to the model. With the desired screw placement determined, I can now build the custom guide. First, I convert the 3D point cloud into a 3D mesh. Here, the resulting mesh is rather messy, but it's accurate where it counts, right where the guide will sit. For the guide, I created an arc-shaped model with openings to guide the drill path along the desired trajectory. The model also includes portions extending from the arc through the model of the vertebra. I shaped the guide in these portions so they conform to the unique bumps and ridges of the vertebra. That way, it only fits in one position, and when it's in place, the drill guide path lines up automatically. With a custom guide designed, it can be 3D printed and used for drilling. For stability, I put the vertebra in a vise and placed the drill guide. I inserted a bushing to avoid damaging the guide with the drill. From there, I can start drilling pilot holes for the pedicle screws, and then place them. So there you have it, custom 3D printed drill guides for placing pedicle screws. However, you might have noticed a few drawbacks. First, because the drill guides are customized, they must be designed and printed for each level of the spine in question. In addition, because they fit across the entire back of the vertebra, they are really only applicable for open surgeries. So, while drill guides solve for accuracy, they lack flexibility, and surgeons often demand both accuracy and flexibility in their surgeries. So, many are turning to spinal surgical robotics. However, that's a topic for another video.